Hello guys, Winston here. Quite recently, I made the decision to eventually put my SpaceX drone ship coasters up for sale, but after getting interest from more people than expected, I realized that I'd have to seriously up my game if I was going to be able to follow through and fulfill that many orders. So I did a bunch of things like fabricating a work holding fixture that would let me batch out a dozen coasters at a time, and refining my overall methodology to maximize efficiency as best I could. More on that in a future video. What I didn't have was a way to mark my coasters in a way that would tactfully promote my identity as a maker. When I made my 5-in-1 branding iron a little while back, I never anticipated that I would need to brand items so small and in such large quantities. The least obtrusive text I could mark my coasters with was my initials, and that does me very little good for marketing myself. Plus, keeping my iron heated up while branding dozens of coasters would be a giant waste of propane, so I was keen to find a better solution. I thought about using my soldering iron as a heat source, but the way you install tips doesn't permit the installation of anything wider than the shank. So instead, I found myself looking for either a cheap soldering iron or a proper wood burning tool. After scouring Amazon, I settled on a 30-watt wood burning tool for two reasons. One, the price per watt ratio was pretty good without sacrificing usability. A lot of dirt cheap irons from China have handles that noticeably heat up after a couple minutes of use. Two, it uses a screw-on tip that I could reverse engineer, would be extremely secure, and would conduct heat consistently. Cheaper soldering iron tips are sometimes held in oversized barrels with a set screw, and I wanted to avoid that. Now, since I'd be working with a tool that had a fixed power output, I wanted to do everything possible to reduce thermal mass on my new branding iron. So I decided to start with smaller individual pieces of stock instead of starting with a giant block of brass and hogging out a ton of material. I purchased from McMaster a length of 5/8 by 3/16 inch thick bar stock, as well as a 3/8 inch square rod. From the bar, I'd cut a 1-inch long piece to serve as the face of my iron. The rod stock I would machine into the interface between the branding iron head and the heating tool. To plan everything out and eventually generate my tool paths, I went into Fusion 360 to model out my components. Please forgive the hand waving here, I do intend on doing a more in-depth Fusion 360 video, but it keeps getting preempted by projects with hard deadlines. But for any of you who are keen on trying Fusion 360, don't be afraid to jump in. Autodesk has some really great tutorials that got me up to speed really quickly. I extruded my text backwards to reverse the letters and put a recess on the back face of my iron head to locate the square rod. On my square rod segment, I'd machine a 0.16 inch diameter stud which I'd later cut threads on with a die. This piece would be brazed to my branding iron head since I have neither the time, nor the money, nor the space to get into welding of any sort. You know that saying, when all you have is a hammer, every problem looks like a nail? Well, this is what happens when all you have is a CNC and you really wish you had a metal lathe. As with my first branding iron, I used progressively smaller end mills to remove material, followed by an external engrave to clean up the small contours that my 1/32 inch end mill couldn't fit into. There were a lot in this project because of its small size, and I even had to create some extra contours to manually notch out with the V-bit. Because of how crucial accuracy was here, I called upon my Nomad for the job. In order to hold my brass pieces above the face of the vice jaws, I machined out a quick and dirty set of parallel bars. These aren't quite machinist grade, but they're close enough that you'd be hard pressed to feel a seam if you ran your fingers over them, so it's good enough for me. Because I had such a tenuous grip on my stock and the Nomad's vise isn't the strongest, I opted to use 1/16 inch and smaller end mills only. The machining process was pretty stress-free because I'd already validated my feeds and speeds with the last brass project. After cutting the front and back of my iron head, I moved on to the threaded interface. I inserted an oversized piece of rod stock in the vise as vertically as I could manage, and started by facing off the ragged side where I'd gone at it with a hacksaw. To ensure that my threaded stud was centered, I used an edge finder. These are really useful for finding reference surfaces, and with a little math you can figure out what your offset is to your desired origin. After I'd milled down my block to the nominal diameter of a number 8 screw, I cut my threads by hand. There's probably a better way of doing this, but as long as you're careful to keep the die as level as possible, you shouldn't have any issues. Then I flipped my block around in the vise and hogged away the 1/4 inch or so of extra material that I'd kept for work holding purposes. It would be so much easier if I could just part off my workpiece on a lathe. Now came the tricky part, brazing. I prepared myself by watching a couple YouTube videos and decided to just go for it. I'd purchased a wood burning tool with an advertised max temperature of about 900 degrees, and even though I doubted I'd ever see that high a temperature with an attachment of this size, I strongly preferred that the mechanical connection between my iron face and the threaded stud be rated to at least that temperature. I chose the copper-based brazing rod that I'm using here because it has a melting point of about 1100 degrees, higher than that of any aluminum brazing rod and well above the melting point of any kind of solder. By the recommendation of multiple sources, I also went with a borax-based flux to pair with my brazing rods. I set up an improvised workstation by perching an aluminum blast shield on top of a wet block of wood. Then I started heating up my branding iron head with propane. There were multiple factors working against me here that I realized far too late. Propane, although it has a flame temperature more than hot enough to melt my brazing rod, doesn't push heat into a workpiece as well as hotter alternatives like oxyacetylene or MAP gas. It also didn't help that I'd placed my workpiece directly on my blast shield, which sucked away a lot of heat. So although I did eventually get my brass pieces up to temperature, the result was an ugly mess. In my clumsiness, I'd even managed to fuse a bit of brazing material to my threads, which meant I'd have to recut them with a die. So I decided to cut my losses and start over. I tried again the next day with a couple upgrades. My updated branding iron head featured extra pockets on the backside that reduced thermal mass by 20%. To further stack the odds in my favor, I crafted a wire cradle to minimize the heat losses through conduction. And finally, I was using MAP gas, which burns 1000 degrees hotter than propane in air. After yesterday's disappointment, I decided that some practice wouldn't hurt either, so I tried brazing some sheets of copper together. I was actually surprised by how quickly I could get them to fuse. Confidence bolstered, I started attempt number 2 of my branding iron. After about a minute or two of heating, I got my brazing filler to run into the seams between my parts. Not the best looking joint, but those 2 spots will provide more than enough strength for my iron. I cleaned up the surfaces with a wire brush and ground flat the back of my iron head. Unfortunately, some material had seeped over the top edge and formed a small fillet against my threaded stud. This prevented me from screwing on the iron completely flush to the heating tool. If I do this again, I'll probably make the base of my interface piece about a 1/16 of an inch taller to make contamination of my threads less likely. Nonetheless, the branding iron worked flawlessly. After giving it 3 to 4 minutes to heat up, it cleanly marked the faces of my test pieces. It would go on to brand dozens of coasters for me. I've had a project like this in mind for about a month or 2 now, but from the time I actually started planning to completion, only took about a week or 2 thanks to quick shipping from Amazon and McMaster, and a well-timed snow day. And that's all I have for this week. I want to thank you all very much for watching, and I'll be back in a week or 2 with another CNC-based project.